Hello and welcome everyone. This will be a quick demo for our project, our task, predicting a student score percentage based on his study hour. This is a task from the Spark Foundation Internship. So let's start in. First, we jump to GitHub, where we have a Jupyter notebook in it. This notebook will be split into four parts. First part is importing the data and making a quick exploration on the data. Second part will be splitting a train and a test data sets from our data. And third, we will create a model using scikit-learn library, linear regression model, and train it. And we will use MSE, mean absolute error, to find how good the model is. And finally, we will answer our main question, which is predicting the score percentage for a student if he worked for 9.5 hours study. Okay, without further ado, let's start in our notebook. First part, we import our libraries with use packages such as NumPy, Pandas, and Matplotlib. Here in this line, we use Matplotlib inline to show the charts inside our notebook. Next, we will read CSV data, student score.csv, and we print, shape, and describe the numerical values and print the head, which is the five first rows of our data, to take an initial look on our data. As we can see from the shape that this dataset have two columns. First is ours, and the second is scores, and we see some statistics for both columns. Finally, we can get a quick look on the head of our table. Okay, next, to know if there is a correlation between ours and the score percentage, we will plot a scatter plot, as you can see, using df.plot, and we will use the hours on the x-axis and dependent variable and the scores on the y-axis. And we also use the function .core, which calculates the correlation between metrics attributes. As we can see that the correlation between hours and scores is 97.6%, which represents a strong positive correlation. So using a linear regression model is a good idea. So let's jump to part two, which is creating a train and test datasets and training the model. First, by using the iLook, first part, when we use first part, we choose all the rows, and next we choose all the columns except the last one, because this is an exclusive, and dot values to get the values of these records, and we put it in X, which represent our training dataset, and Y will be all record last column values in the data, which is a test, which is the label. Then we import from scikit-learn the model selection to have the train test split function and linear regression model and mean absolute error metrics. First, we start by using the train test split method to get the X train and X test and Y train and Y test with a test size of 0.2 and a seed of 42 to make the results consistent every time we run the code, we first initiate the model by calling the constructor and making a fit using the X-train data and the Y-train data. Then we call the model and we plot a scatter plot first. We need to plot the linear regression line. So it's split into two parts. First part is creating a scatter plot for the X and the Y, and second, plotting a line using the equation of a linear line which equal y equal mx plus c, which c is the y-intercept and m is a slope. So as we can see here, we get from the model the coefficient, which is representing m, multiplied it by x column, plus the model dot intercept, which is the y-intercept. We have the graph. So after we see this, we move to part 3, which is a prediction. We predict the model. We make the model predict on the X test and put it in Y prediction, and we make sure we want to look at the actual data that we split it before, which is Y test and our Y predict. As we can see, the actual was for the first record was 81, while we predicted an 83%, which is somehow good. But for more efficiency, we use the mean absolute error method to find the mean absolute error. It's a metric that represents how good the model is trained. You could show some video on it. It needs some explanation, and we find it 3.9, which somehow acceptable. And final part of the notebook is we going to answer the question on hand, which is predicting the score for a student who studied for 9.25 hours. We use the model predict. We must pass the answer as an NP array because the predict take only array. So we used numpy.array and pass the value, then reshape it to be a single value matrix, and we get the prediction. And finally, we predict that for studying for 9.25 hours, it's predicting to score 92.39%. That's all. Thank you for listening, and goodbye.